Hi, my name is T.Bhuvana Darsini. I'm studying second year in the stream of ECE. My roll number is 24BQ1804G7. Today, my topic is about adders and subtractors. Introduction. In digital electronics, arithmetic operations forms the basics of digital circuits. Addition and subtraction of binary numbers are essential in computers. Circuits used are half adder, full adder, half subtractor, full subtractor. These are used for performing arithmetic operations. These applications are ALU, Arithmetic Logic Unit, processors, calculators. These are used in this. Let's talk about half adder. Its definition is a half adder is a basic combinational logic circuit used to perform the addition of two single bit binary numbers. It has two inputs and two outputs. Unlike a full adder, it does not consider any carry input from previous stage, which is why it is called a half adder. A half adder is a combinational circuit that adds two binary digits. It provides two outputs, sum and carry. Sum, it represents the least significant bit of addition, while the carry represents overflow. Carry is generated only when sum is overflowed. Limitations. It cannot handle carry input from the previous stage, which means we cannot take carry input carry as input from the previous stage. For a half adder, the logic is if you take inputs A and B like this, A and B, both going into an XOR gate, you get sum. For sum, it is XOR gate, and for carry, it is AND gate, which is this way. You get carry. This is XOR gate, and this is AND gate. We get sum for XOR gate and carry with AND gate. Half adder truth table. We can observe that the inputs are A and B and the outputs are sum and carry. If we are given 0, 0 input, we get sum 0, carry is also 0. If we are given 0 and 1, sum gives 1, while carry is 0. If we are given 1 and 0, sum is 1 and carry is 0. If we are given A 1 and 1, sum is 0 and carry is 1. We can observe that for sum, it is XOR gate, and for the carry, it is AND gate. Let's talk about full adder. Full adder definition. A full adder is a combinational logic circuit that performs the addition of three binary bits. Unlike a half adder, which only adds two bits, a full adder also consists the carry from previous addition, which means in a half adder we cannot take carry from the previous, but we can take right now. This makes it suitable for multi-bit binary addition. A full adder has three input bits. Those are A, B, and C in, that is carry in. Produces two outputs. Those are sum and C out, carry out. It overcomes half adder limitations, which is it cannot take carry from previous addition. Full adder logic. For a full adder, the logic is as follows. We can perform a full adder by using two half adders in this way. If we take A input and B input, we get sum and carry. And the carry is let's talk about it later. And C input also goes into a half adder. We get carry and sum. This sum is the sum. And this carry goes into an OR gate. These two carries are going into an outlet. We get C out. This is C out and this is sub. For a full adder, the truth table is as follows. If we are given A, B, C as inputs, we get sum and C out as outputs. If we are given even number of ones, we get sum as 0. If we are given odd number of ones, we get sum as 1. As for carry, if there is more than one number of ones, we get 1. Let's move on to the next topic, subtractors. Introduction. A subtractor is a combinational logic circuit designed to perform subtraction of binary numbers. Similar to the adders, subtractors are also two types, half subtractor and full subtractor. Subtraction is also is as important as addition in digital systems. Circuits used are half adder for subtracting 2 bits and full adder for subtracting 3 bits, including borrow. Let's talk about half subtractor. Definition. A half subtractor is a combinational logic circuit that performs a subtraction of two single bit binary numbers. It produces two outputs, difference and borrow. Unlike the full subtractors, it does not consider any borrow input from previous stage, which is why it is called a half subtractor. A half subtractor is a combinational circuit that subtracts two single bit binary numbers. Inputs are A minus 10 and B subtract 10. Outputs are difference, which is A XOR B, and borrow, which is A bar and B. Half subtractor truth table is as follows. For the inputs A and B, we get difference and borrow as outputs. If we give 0 and 0, we get 0 and 0. If we give 0 and 1, we get 1 and 1. If we give 1 and 0, we get 1 and 0. If we get 1 and 1, we get 0 and 0. We can observe that for difference, it is following XOR operation. As for the borrow, we can observe that it is following A bar and B. Let us move on to the next topic, full subtractor logic. A full, subtract, a full subtractor is a combinational logic circuit that performs subtraction of three input bits. Those are minus 10, A, subtractant B, and borrowing. It produces two outputs, difference and borrowed. It can subtract one bit digit from another, considering whether a previous borrow has occurred. A full subtractor can be constructed by using logic gates XOR and OR NOT. Another method is used, two half subtractors and a OR gate. In these two methods, we can construct a full subtractor. The first half subtractor subtracts A and B, giving an initial difference and borrow. The second half subtractor subtracts the initial difference and B. The final borrow is obtained by ORing the two borrow signals. It means if you are using two half subtractors, the process is as follows. For the difference, the logic is A XOR B XOR B in. B out equal to A complement B plus A complement B in plus B into B in. A full subtractor truth table is as follows. You can see that A, B, and B in are inputs, and difference and B out are outputs. We can observe that we are getting 1 for odd number of ones. Like here we get 1 for odd number of ones, and ones for odd number of ones. And for even number of ones, we are going to get 0. As for the B out, we follow the logic. Applications of adders and subtractors. For adders, the applications are digital calculators, CPUs and microcontrollers, arithmetic logic units, multipliers, and arithmetic circuits. For subtractors, digital subtraction operations, ALUs in processors, multi-bit arithmetic circuits used also used in combination with adders for adding or subtracting operations. Finally, the conclusion is half adder means adds 2 bits, no carry input. For a full adder, it adds 3 bits, includes carry input. For a half subtractor, subtracts 2 bits. For a full subtractor, it subtracts 3 bits, including borrow input. Together, these circuits are essential for digital arithmetics. Thank you.